Okay. Hi guys, so today we're going to look at parallel and perpendicular lines here. So this lines up with exercise 2E in your textbooks. So the first thing we're going to look at is parallel lines. So as we've discussed before, if two lines are parallel, it means they must have the same gradient and it means they will never intersect. So M1 would be equal to M2. So if you have two lines, for example, y is equal to 2x plus 3 and y is equal to 2x minus 8, as we have here, you'll notice that the lines both have the same gradient of 2 when you look at the standard form for a line. Therefore, they must be parallel. So moving on to perpendicular lines, which is a bit more complicated here. The rule for perpendicular lines is if the two lines are perpendicular, they will M1 multiplied by M2 will always equal to -1. So, and that's where M1 and M2 are gradients for these two lines. So that might be a bit unclear now, but if we go through a couple of examples, this will make a lot more sense. So the example we're going to go through is find the equation of the straight line which passes through the point 0, 2 and is parallel to the line y minus 2x is equal to 6. So when we look at a question like this, immediately you should be thinking, all right, we've got the point, we can find out the gradient because we've got a parallel line, and therefore we can solve it. So with this line y minus 2x is equal to 6, we can find what the gradient is by simply getting the 2x to the other side and making y the subject. So y is equal to 2x plus 6. Therefore, m1 is equal to 2. So therefore, you've got a line with gradient m equals 2 passing through point 0, 2. So you've got a point and the gradient. So we just use the point gradient formula. So y minus y1 is equal to m side of x minus x1 from our last class. Okay, so substituting in the points, we've got y minus 2 is equal to, so we've got the 2 up there, is equal to 2 outside of x minus x and x1, and in this case that's 0. So, sorry about that. Therefore, a bit further down, give us a bit more space. So y is equal to 2x, expanding the brackets, and then you just add the 2 from the other side, plus 2. So that would be your answer for the first one. So the line that is parallel to that, passing through the point 0, 2, is y is equal to 2x plus 2. For the second one, we've still got the point, so we need to find the gradient here. So once again, we know that perpendicular to the line with a gradient of m equals 2. Now you figured out that gradient up here. So therefore, we know that m1 times by m2 has to be equal to -1 because the lines are perpendicular. So the first line we know is 2, and we're trying to find the gradient of the second line, m2. So that's what we're trying to find because we know this line's perpendicular to the original line. So 2 times by m2 is equal to -1. Therefore, m2 is equal to a -1/2. Okay? So we've got that now, and we know this one also passes through the point 0, -2. So we'll put that down there just so you're showing you're working through the point 0, 2. So therefore, y minus 2, using the point gradient formula, is equal to a -1/2 outside of x minus 0. So therefore, y is equal to -1/2 x plus 2. So that's a line perpendicular to that point there. Okay, so make sure you're copying these examples down in your book. You can also have a look at example 19 for another way that you can use the perpendicular line rule to help you find the equation of a new line. Okay, so exercise 2E we'll be working on for this one.